Hello everyone. In this video, I will be talking about learning objectives 5 and 6 of week 5. So first of all, learning objective 5. Summarize the use of confidence interval estimates and also discuss the point estimates. You know, as I mentioned in a previous lecture video, that in business research, we typically follow inferential statistics. That means we estimate sample parameters and use these sample estimates to make inference about population. Now the question is how correct we are, or how confident we are that these sample estimates or sample parameters reflects our population parameters. Let's take an example that you are doing a coffee test study, and you have distributed some coffee to 100 respondents. You ask them to test the coffee and call back to talk about the taste of the coffee. Okay. Now, after testing the coffee, your respondents call back, and 85% of the respondents say that they like the coffee. Now, since 85% respondents like the coffee, you become very happy and you plan that you will introduce this coffee in the market. Now, the point is you need to understand that this 85% positive response, it's actually from your sample, not from your population. So the question there must be that how good or how correct these estimates that 85% people is positive about the coffee, how correct that these 85% is also will be applicable for the population. And so that's why we use different estimates like point estimates or confidence interval estimate. When we use point estimate, we use a single sample value, for example, the mean value, to make inference about population. For example, we take the sample mean and we make inference about the population mean. However, you understand that sample mean will be exactly same as the population mean is too much optimistic idea, and if it can happen if we are extremely lucky. However, this is very much risky to make inference about the population based on only one sample value. That's why we might use confidence interval estimate. In confidence interval estimate, we take the sample parameter and we plus minus error to get an interval, and we expect that our population parameter will lie within that interval. For example, if we take the same example that 85% of our respondents answered positively about the coffee test. Now, let's assume that there is a 5% chance of being error. So we add this 5% and deduct 5%. So 85% plus 5% is 90%, and 85% minus 5% is 80%. So we get an interval 80% to 90%. And we will expect that our population parameter will lie within this interval. So you understand that using this confidence interval is a less risky approach compared to using a point estimates. Then confidence level. Excuse me. Confidence level is something different from confidence interval estimates, because in confidence interval estimates, as I discussed, we use an interval where we expect our population parameter to lie. However, in confidence level, actually we reflect by using a particular percentage or a decimal value, we want to reflect how confident a researcher is that their inference is correct. We typically use 1%, 5%, and 10% confidence level. So when we use a 1% confidence level, it means that the researcher is 99% confident of being correct. So there is 1% chance of being wrong. It means that in every 100 cases, the researcher expects that one inference will be wrong. In excuse me. When we use 5% confidence, 5% chances of error and 95% confidence level, it means that the researcher is 95% confident of being correct. So for every 100 cases, 5 cases will be wrong. When you use 10% significance level, actually a researcher is 90% confidence of being correct. So for every 100 cases, there is a chance of 10 cases being wrong. So this is the confidence level. Now, we are talking about this confidence level and chances of making an error. We need to remember that there is an inverse relationship between this random error and sample size. That means larger the sample size, the less chances of making a mistake. For example, look at this diagram. Here in the horizontal axis, we show sample size, and in the vertical axis, we show the random sampling error. And you see that larger the sample size, smaller the random sampling error. I believe that you didn't forget random sampling error. We learned it in the previous week before last week. So random sampling error means when you take a sample and the sample parameters or sample estimates differ from population estimates, or there is a chance that sample parameters will differ from population parameter. This is random sampling error. And larger sample size means that your random sampling error is smaller. It means that your sample parameters more closely and more correctly reflect your population parameters. The loss learning objective 6, some major issues in specifying sample size. We need to consider these 3 factors: variance, magnitude of error, and confidence level in determining our sample size. First of all is variance, or you can say heterogeneity or homogeneity of population. If your population is heterogeneous, then your sample size has to be larger. And if your population is homogeneous, then your sample size has to be smaller. Let me give you an example. Let's say that your population is year 10 students. Okay, so year 10 students. Now, if you want to find out the age of year 10 students and pick up a sample, then it's very likely that their age will be very close to one another. Okay, another sample, you take the Jew visitors. You want to take average age of Jew visitors, so you pick up a sample. Now look, in both cases, you want to take average age, but in the first case, average age of year 10 students, and in the second case, average age of Jew visitors. Probably you understand that year 10 population is homogeneous. However, Jew visitors in terms of their age must be heterogeneous, because Jew visitors they may be from very young child to very senior citizens. However, year 10 students will have very much homogeneity in terms of their age. So when it's the case of year 10 students, we can take a smaller sample size, and when it's the case of Jew visitors, we have to take a larger sample size because of the heterogeneity. The second one is magnitude of error, or confidence interval. That means how precise you want to be. If a researcher wants to be more precise in terms of results, then a sample size has to be larger. Okay, and if a researcher is not very much concerned about the preciseness of the result, or may take some more degree of error, then sample size can be smaller. And last of all is the confidence level, how tolerant you are to error. If a researcher is more tolerant to error, then a smaller sample size is fine. But if the less tolerant to error and want to have the very much confident about the accuracy or correctness of the result, then sample size has to be larger. So this is the end of week 5 lecture video. Please ask me if you have any question by email or by posting your questions in general discussion board. Thank you very much.